greenhouse gases represent a tiny, tiny fraction of the air in the atmosphere. For example, CO2, which is the one that is doing most of the heating, okay, is around about 4 parts in 10,000. It's a tiny fraction, okay, but that tiny fraction is all you need to actually warm the planet up, okay?
Yeah.
And what happens is the sunlight comes down, it warms the planet, and then naturally the warmth radiates back into space. So the energy comes in, the energy goes out. The greenhouse gases trap some of that energy and help to distribute heat around the planet, which explains why it can be warm at night, because the space is like minus 270 degrees Celsius, but it's the gases in the atmosphere that are trapping the heat. If you add too much of that greenhouse gas, it gets too hot. And if it gets too hot, then living things start to perish. Okay. So what we saw in an event called the Permian Extinction 253 million years ago, obviously we weren't here to see it, right? But the scientists have got all of these tools to understand what happened back then. There were these massive volcanic eruptions that released vast amounts of CO2 predominantly, but also methane. These went on for around 300,000 years. And in that time, all of the natural systems, which are basically help to maintain the temperature of the planet, this is what nature does, this is called Gaia theory, kept on top of it. But then what happened was there was these huge lava plumes that hit these coal fields, and then the greenhouse gases went boom, temperatures went way up. The ocean became acidic because a lot of that CO2 absorbs into the ocean to create carbonic acid. And basically 90% of everything that was living on the planet died off. All right. Once the fires went out and everything got back together and the forest started to grow back again and pull carbon out the atmosphere, 10 million years later, we were back to business. There was lots of animals and plants and it was back to business again. We are doing exactly the same thing. We're just doing it about 10 times faster than the Permian extinction. And this is the point that we're trying to get people to get their head around, is that this we're in the exponential phase now. And that in an exponential curve, as they call it, it's very flat to a certain point and then it goes up very sharply. We're entering this part now. And so we're out of time